Right now, in a quiet building in Houston, a team of scientists is still working through a pile of images that did not exist 6 months ago. More than 7,000 photographs of the moon. Not taken by a robot, not stitched together from orbit by a satellite. Taken by 4 people, by hand, through a window, while moving faster than any human being had moved in more than half a century. Some of those pictures show ground no human eye had ever looked at directly. Not through a telescope, not on a control room screen, but through glass, from close enough that the craters had shadows. And here's the strange part. The single most important thing that crew saw is not in any of the photographs. It could not be, because the equipment was not capable of catching it. 4 people watched something happen on the surface of the moon in real time, with nothing between them and it but a pane of glass, and every camera on board failed to record a single frame. They came home and told the scientists what they had seen, and a room full of researchers at Johnson Space Center in Texas started screaming with delight. This is the story of Artemis II. 10 days, 4 crew members, a rocket that almost did not fly at all, a waste system that failed on the way to the moon, and a return through the atmosphere at thousands of degrees behind a heat shield built to a design that had already come back damaged once before. It is also the story of what happens when you send people back to a place we walked away from in 1972 and hand them equipment the Apollo astronauts could not have imagined. For 53 years, almost everything we knew about being near the moon came from film sitting in canisters that had to survive launch, radiation, and re-entry before anyone on Earth could know whether the pictures had come out at all. That is not how it works anymore. And by the end of this, you will understand why one of those 4 people asked for a crater to be given a nurse's name. Start with what this flight was supposed to be, because the modesty of the plan is the whole point. Artemis II was not a landing. Nobody touched the surface. Nobody even entered orbit around the moon. On paper, it was a shakedown cruise, the kind of cautious, unglamorous test flight that engineers love and headlines ignore. Fly the Orion capsule with people inside for the first time. Loop around the moon on a path that physics itself would bring home and find out what breaks. Orion had flown once before, empty, on Artemis I in 2022, which proved the rocket could lift it and the shape could survive coming back. What that flight could not prove was whether the spacecraft could keep 4 human beings alive and working for 10 days, scrubbing their air, holding their water, letting them sleep and exercise and handle waste. With screens and hand controllers, they would have to trust with their lives. The crew was Commander Reid Wiseman, pilot Victor Glover, and mission specialists Christina Koch of NASA and Jeremy Hansen of the Canadian Space Agency. Koch became the first woman ever to travel around the moon. Glover became the first person of color to fly a lunar mission. Hansen became the first Canadian ever to travel beyond Earth orbit. They named their spacecraft Integrity, and NASA said the word stood for the trust, respect, candor, and humility of the thousands of people who had assembled more than 300,000 components into a ship. That was the mission. Check the boxes and come home. What actually came back was a scientific haul nobody had planned for, and one observation that changed how NASA thinks about sending people out to look at things. But the flight almost did not happen, and the reason was a guess that barely made the news. On the 19th of February, 2026, the Space Launch System rocket sat on the pad at Kennedy Space Center in Florida and got through a wet dress rehearsal, a full practice countdown with the tanks loaded and the clock running. It was the second attempt, after an earlier run at the start of the month was cut short by hydrogen leaks. This one worked. 2 days later, during routine work afterward, engineers noticed something wrong with the helium. Helium is the quiet workhorse of rocketry. It does not burn, and it does not react with anything, which makes it the ideal gas for pushing other things around. On that upper stage, it kept the engine in the right condition to start, and it pressurized the tanks of liquid hydrogen and liquid oxygen so the propellant would flow instead of sitting there. Without steady helium, the stage is not safe to fly. The flow had been interrupted. Teams looked at the connection between the ground lines and the rocket, at a valve inside the stage, and at a filter between the two, and pulled up data from Artemis I, which had fought similar pressurization problems. Then they made the expensive call and rolled the rocket back to the vehicle assembly building. That decision cost them the March launch window outright. 4 astronauts who had been training for years watched their ride get towed back indoors. The only thing they saved was April, and only if the repair went perfectly. It did. On the 1st of April, 2026, at 35 minutes past 6 in the evening Eastern Time, the Space Launch System lit up Launch Pad 39B with roughly 8.8 million pounds of thrust and threw 4 people at the moon. The first thing they did up there had never been done by an Apollo crew, and it happened before most viewers had finished celebrating the launch. Once the upper stage finished its job and separated, it did not simply drift away as garbage. It became a target. Wiseman and Glover took manual control of Orion and flew the spacecraft around that spent stage, closing in, backing off, holding position, using the same eyes and hand movements they would need to line up on a docking port. Astronauts had never flown Orion by hand before. Almost everything that spacecraft does, it does automatically. That matters because of what comes next. On future missions, Orion has to find a lander in space and physically connect to it, with crew inside both vehicles. Then came the burn that committed them. The main engine fired to push Orion onto a path toward the moon, and that path was chosen with a specific kind of paranoia in mind. It was a free return trajectory. If every engine had failed at that moment, the moon's own gravity would have swung them around and thrown them back at Earth anyway. The physics itself was the backup plan. What separates this flight from every crewed lunar mission before, it is not the rocket or the capsule, it is the pipe. When Apollo 11 landed in 1969, the video that hundreds of millions of people watched was a ghost. It was sent using a slow scan television system squeezed into whatever bandwidth the radio link could spare, then pointed at a conventional camera and rebroadcast, which degraded it further. The result is that famous, smeared, high-contrast image of a man on a ladder that looks more like a memory than a recording. Apollo carried the best television anyone could build. The job was simply too hard because radio waves spread out enormously over that distance and only so much information will fit through them. Artemis II carried a laser instead. Bolted to the spacecraft was an optical communications terminal that sends data home on a beam of infrared light rather than radio. Light at that wavelength can be packed far more tightly, which means far more information per second. The system was rated at up to 260 megabits per second, which is enough to carry live 4K video from lunar distance, ordinary home internet speed, arriving from 250,000 miles away. The beam was caught by receiving stations at White Sands in New Mexico and Table Mountain in California. With the new third site at Mount Stromlo Observatory near Canberra in Australia added for Southern Hemisphere coverage. So here is what that meant in practice. People on Earth watched the moon in high definition, live, through a camera held by a human being who was standing next to it. NASA broke its own streaming record on this flight, with nearly 24 million views on launch day and close to 1.5 million people watching the lunar flyby at the same moment. Not a recording released weeks later, and not a grainy transmission, but a clean, moving picture of another world arriving in real time. This is where the story changes, because once you can send that much data home, it finally makes sense to bring cameras worth using. Orion carried 32 cameras and video devices. 15 were bolted to the spacecraft itself, and 17 were handheld, which is more than 4 handheld cameras for every person on board. The handheld set included professional Nikon bodies, action cameras, and iPhones, with lenses running from a 14mm wide angle all the way out to a telephoto that reached 400mm. 4 of the mounted cameras sat out on the solar array wings, which meant the crew could turn the spacecraft's own eyes back on itself and photograph the outside of the ship in flight, checking for damage and, incidentally, taking the best selfies in the history of the species. Christina Koch posed for one of those wing cameras from inside the cabin, holding the mission's small stuffed zero-gravity indicator, a toy named Rise. Compare that with the most famous photograph ever taken of Earth from deep space. On Christmas Eve of 1968, Bill Anders looked out of Apollo 8, saw our planet climbing over the lunar horizon, and grabbed a Hasselblad film camera with a 250mm lens. He got the shot. Then he had to wait. The film sat in a canister through the rest of the mission, through re-entry and recovery and processing back on Earth, before a single person could confirm that Earthrise existed. The most important photograph of the 20th century spent days as a rumor. The crew went through roughly 20 hours of specialist photography instruction before launch, learning exposure and focus the way a professional would, because NASA had worked out something obvious that had never quite been true before. If you are going to spend billions putting eyes near the moon, teach the eyes how to shoot. By flight day 5, they crossed a line you cannot see. Every object between the Earth and the moon is being pulled by both, and at a certain point the moon's pull wins. When Orion crossed that boundary, the crew stopped falling away from Earth and started falling toward the moon. Flight day 6 was the day the mission was built around. Orion swung around the far side and came within 4,067 miles of the surface, close enough that the moon looked about the size of a basketball held at arm's length, and far enough that they could take in the whole curve of it at once. 3 minutes before they lost the signal, at 41 minutes past 6 in the evening Eastern Time on the 6th of April, they caught the mirror image of Apollo 8. Earth lit as a thin crescent sinking below the lunar horizon. Not Earthrise, Earthset. In the photograph, you can pick out Oceania, white cloud and blue water, with the night side of the planet swallowing the rest. Christina Koch, looking at that same planet from that same distance, said something that belongs on a monument. Everything we need, the Earth provides, she said, and that in and of itself is somewhat of a miracle. Then the radio went quiet. A laser cannot pass through several thousand kilometers of rock, and neither can a radio wave. As Orion passed behind the far side, the moon put itself between the crew and every antenna on Earth. For roughly 40 minutes, 4 people were completely alone, with no way to ask anyone anything, and no way for anyone to reach them. Jeremy Hansen tried to describe it afterward. When they were on the far side, looking back at Earth, he said, "You really felt like you were not in a capsule. You had been transported to the far side of the moon, and it really just bent your mind." At their farthest, they were 252,756 miles from home, breaking a record that had stood since 1970. Apollo 13 held it at 248,655 miles, and only because that crew's spacecraft was crippled and had to take the long way around a moon they never got to land on. Artemis II beat it by roughly 4,100 miles, on purpose, with everything working. The signal came back, and a little over an hour after that, the sun went out. From where Orion sat, the moon slid directly in front of the sun, a total solar eclipse seen from lunar distance with the moon as the thing doing the eclipsing. The disk went black, and around its edge a ring of pale light burned outward in every direction. Scientists are still arguing about how much of that glow was the sun's outer atmosphere and how much was dust scattered along the plane of the solar system. Totality held for the better part of an hour, and while it did, the crew could pick out Venus, Mars, Saturn, and Mercury hanging in the dark beside them. Victor Glover narrated it on the loop, and the professional flatness went out of his voice. "This continues to be unreal," he said. "The sun has gone behind the moon, and the corona is still visible." When the light finally started climbing back over the lunar edge, he reached for the word other people had used for it. The most popular term, he said, is baby hair. If a story like this is why you are here, subscribe, because the next few years of this program are going to be full of them. Now the story gets stranger, and it involves the one thing all that expensive glass could not do. Wiseman described the sequence later. The eclipse happened, then there were about 5 minutes of raw human reaction, and then somebody in the cabin said, "Let us look for impact flashes." So they looked, and they started seeing them, brief points of light appearing on the dark ground below and vanishing. Not reflections, and not instrument glitches, impacts. The moon has no atmosphere, so nothing burns up on the way in. A pebble arriving at tens of thousands of miles an hour hits bare rock and releases its energy instantly as a flash of light. Astronomers on Earth have been recording these events with dedicated telescopes for decades, but only on the near side, because the far side never turns toward us. No crew had been in position to watch that hemisphere with their own eyes since Apollo 17 in 1972. NASA's post-flight count came to 6, and their cameras got none of them. The flashes are faint, they last a fraction of a second, they happen without warning, and they can appear anywhere across an enormous surface. A camera has to already be pointed at the right spot, at the right exposure, at the right instant. A human scanning the whole disk with the finest motion detection system in the known universe wired into the corner of their vision does not have that problem. Kelsey Young, the lunar science lead for the mission, said it directly. "It is extremely difficult to capture impact flashes with a camera," she said, which is one of the benefits of sending trained crew to observe the moon. When those observations reached the science evaluation room at Johnson Space Center, the reaction was not what you picture from Mission Control. "I heard there were audible screams of delight," Young said. "Spirits are very high," she added. "We did what we set out to do. There's a hard, practical reason that mattered. NASA intends to put a base near the moon's south pole, and every one of those flashes is a data point about how often things hit and how much energy they carry, which feeds straight into how thick the walls of a habitat need to be. Put them together with amateur astronomers on Earth and the orbiting lunar reconnaissance orbiter hunting for the fresh craters afterward, and a hazard that used to be a guess starts to become a number. 4 people, looking out of a window in the dark, quietly improved the safety case for building on another world. All of which sounds serene, and none of it was, because a spacecraft is also a machine full of plumbing. Hours into the mission, before the burn that would raise their orbit, a fault light started blinking on the waste management system. Orion's toilet had stopped working properly. It is easy to make a joke of that, and everyone did, but consider the actual position. 4 adults, 10 days, a pressurized cabin, roughly the volume of 2 minivans, and no possibility of opening a window. A failed toilet on a lunar mission is not a comedy problem. It is a mission-ending problem. So the crew and the flight controllers in Houston did what that partnership has always done. They read the data, worked the fault, and talked to each other through the repair while the spacecraft kept accelerating away from any possibility of help. They cleared it, and the crew carried on to the moon. But that system was not finished with them. 2 days later, there was a burning smell in the cabin, and the waste unit stopped venting stored urine the way it was supposed to, which left 4 people on a lunar mission working out of contingency bags. NASA is still chasing the root cause of the vent line failure, and the fix has to be in place before anyone flies again. Before they left the neighborhood, the crew did something that has to be voted on by an international committee before it becomes real. Passing over ground on the 6th of April that had never been described up close, they picked out a crater roughly 6 kilometers wide, about 3.7 miles, sitting northwest of the vast Oriental Basin, and gave it the name of their ship, Integrity. It stays unofficial until the International Astronomical Union formally adopts it, but the paperwork is in. Then they named a second one, and the loop went quiet. Jeremy Hansen spoke first. He picked out a bright spot on the moon northwest of a crater called Glushko, sitting on the boundary between the side of it we see and the side we never do, and said the crew would like to call it Carroll. Carroll Taylor Wiseman was a pediatric nurse practitioner and a school nurse who had spent years working in a newborn intensive care unit, holding other people's children through the worst nights of their lives. She was Reid Wiseman's wife. She died in 2020, leaving him and their 2 daughters, Ellie and Catherine. Wiseman flew to the moon as a commander, as a widower, and as a single father. And when his crewmates said her name out loud, he broke, and the 4 of them pulled into a group hug in zero gravity 250,000 miles from anyone. Apollo brought back rocks. Artemis II brought back a place on the map with a nurse's name on it. Coming home is where the previous flight had left a wound, and everybody knew it. When Artemis I returned empty in 2022, its heat shield lost more material than expected. Chunks of avcoat, the protective outer layer designed to burn away in a controlled fashion, came off in pieces rather than eroding evenly. Engineers traced it to gases building up inside the material faster than they could escape. On an uncrewed test flight, that is a finding. With 4 people inside, it is something else. The fix was not a new shield. It was a new way of falling. Orion came in on a lofted skip profile, dipping into the upper atmosphere, climbing partway back out, and then descending for real. That pause lets the avcoat vent, so pressure never builds to the point where it tears the surface apart. Wiseman explained it in the calm register test pilots use for terrifying things, saying the teams had run wind tunnel testing and laser testing and hypervelocity testing, and had decided the lofted profile would be safe to fly. On the 10th of April, they hit the atmosphere at about 24,000 miles an hour, nearly 35 times the speed of sound, with engineers putting the peak temperature on the outside of that shield at somewhere around 5,000 degrees Fahrenheit, close to half the temperature of the surface of the sun. 2 drogue parachutes caught the capsule at around 300 miles an hour, and 3 main parachutes brought it down to about 20. Integrity splashed into the Pacific off San Diego, 2.9 miles from its aim point, with an entry velocity within 1 mile an hour of what the models had predicted, and the USS John P. Murtha went out to collect it. The post-flight inspection said what everyone needed to hear. Char loss was significantly reduced compared with Artemis I in both the number and the size of the missing pieces, and it matched the ground tests. The heat shield did its job. The plumbing was the part that let them down. So bring it back to today, because this is not a story that is finished. On the 9th of July, 2026, 3 months after 4 people climbed out of a capsule in the Pacific, technicians inside the Vehicle Assembly Building at Kennedy began stacking the solid rocket booster segments for Artemis III. 2 of the 4 main engines for that rocket had already arrived in June. Nearby, the next Orion is getting its heat shield, 186 blocks of avcoat made with far tighter control over uniformity and permeability, which is what actually failed on Artemis I. Artemis III flies next year, and it is another deliberately unglamorous mission. Randy Bresnik commands, with Luca Parmitano of the European Space Agency as pilot and Andre Douglas and Frank Rubio as mission specialists. They stay in Earth orbit and practice docking with test versions of the commercial landers. Then Artemis IV, in 2028, is meant to put boots on the lunar South Pole. There have been quieter endings too. Jeremy Hansen, the first Canadian ever to fly to the moon, announced this month that he is retiring from the Canadian Space Agency, weeks after coming back from the far side. And one date is still ahead. NASA has committed to putting the mission's science hall into the public record within 6 months of the flight, which means by October. Roughly 11,500 image and video files of the Earth and the Moon, plus more than 100 science audio recordings with written transcripts published openly through the agency's planetary data system. That last part is the one to wait for. It is the raw commentary of 4 people describing the Moon out loud while they were looking straight at it, released alongside the frames they were describing. If you want to see it when it lands, stay subscribed. Here is what stays with me about all of it. For 53 years, the moon was somewhere we used to go. It became a thing our grandparents did, preserved in scratchy footage and a handful of photographs, close enough to see every night and far enough away to feel finished. A whole generation grew up being told that humans had walked there and quietly filed it under history rather than capability. Then 4 people went back. And one of the first things they proved was that our machines are still not as good as our eyes. All that glass, all that laser bandwidth, all that computing power, and the observation that made scientists shout across a room came from a person looking out of a window and saying, "I just saw a flash." That is the argument for going. In the end, not the flags and not the records, but the fact that a human being in the right place will notice something no instrument was pointed at. And there is Carroll, sitting on the line between the side of the moon we can see and the side we cannot. A small, bright crater named for a nurse who never left the ground and who is now on the map of another world. Nobody will visit it. Nobody needs to. It is up there tonight, in the dark, exactly where 4 people said it should be. Go outside and look up. That far side is still turning away from you, still holding the ground where the flashes happened, still carrying a name that a husband could barely say out loud. Still there, still bright, still ours.